Hello, good afternoon. Welcome back to a new video. Today, we will learn about the Coulomb's law. So, what is Coulomb's law? Today, we learn about Coulomb's law, right? It is similar to Newton's gravitational law, right? But the Newton's gravitational law is about the masses, but Coulomb's law is about the charges, right? So here one side we will write the gravitational force formula G m1 m2 divided by r square. So keep it remembered, keep it in mind that this one, it is Newton's gravitational law. Similarly, if we define the Coulomb's law actually defines on the point charges. So what do you mean by point charges? First, point charges. Point charges are nothing but the charges. If we will take the two charges q1 and q2, the separation between those two charges will be greater than the radius or the size of the charges. These charges are called point charges. Once again, the point charges are charges in which the separation between those charges will be much greater than the size of the charges. So here the law states that the force the force of attraction, the force of, suppose this both charges will be of similar charge, so here will be the repulsion force F12 and here F21. So the distance, let be the distance r. So this force states that the force of attraction or repulsion between the two charges, 2 point charges, will be directly proportional to the product of the charges, and it is inversely proportional to the square of the distance between them. Square of the distance between them. And if we remove the proportionality constant, it will become it will become F is equals to K Q1 Q2 divided by R square. So here K is the proportionality constant. K is proportionality constant. Let us know some properties of this Coulomb's law. This, according to the Coulomb's law, the force will be acting always to the line joining two charges. See, here are two charges, but the force is acting to the line joining the two charges. It is acting towards this. It is not acting towards like this, right? So the force always act towards line joining the two forces. Force acts towards the line joining to the two charges, and this law will obeys the inverse square law, because The force is inversely proportional to the square of the distance between the two charges. Obeys inverse square law. And this is this law is similar to the gravitation, Newton's gravitation law, as we know. And let us know about this proportionality constant, that is k. So the k, actual value of k, is equals to 1 by 4 pi epsilon naught, where epsilon naught is absolute permittivity. Absolute permittivity, right? So here, if the, yeah, this is in air or vacuum. This is absolute permittivity, and this is permittivity. In medium, any medium, right? So the grand total value of k is equals to 9 into 10 power 9. If we write the unit for it, means force, force unit is Newton, meter square divided by Coulomb square. This is the value of k, right? Yeah. So here is the Coulomb's law. Now let us compare the Coulomb's law and the Newton's gravitational law. One side we will write Coulomb's law, and another side gravitational law. So first, he here Coulomb's law acts between. So the Coulomb's law acts between the charges, between the charges, and here the gravitational law will act between the masses. So here the force may be attractive force or repulsive force. Force may be attractive or repulsive. Here only attractive force, attractive force, right? Both the laws in obeys the inverse square law. Yeah, inverse square law.